Hello, this is Miguel speaking, and I'm going to present this talk about the SpreadDEM, a GiD-powered commercial software. First of all, let me present the team. This is me, but I have Guillermo Casas by my side in that picture. We also have Marcel Lopez, we also have Farana Rufat, and finally Diego Aguilera. These are the people involved in the development of SpreadDEM. We all work in CIMNE, that is the International Center for Numerical Methods in Engineering, which is located in Barcelona. CIMNE is a consortium between the Catalan government and the UPC. And basically, like the third bullet point says, it's focused on bridging the gap between the academia and the industry, so trying to use algorithms to be transferred and used by the industry. And inside CIMNE, GiD was fully developed. The GiD team is in charge of developing the pre and post processor, but also some people are working on Kratos. Kratos is made outside of CIMNE but part inside also, and Kratos is a multiphysics open source code. Inside Kratos you can find solids, you can find fluids, you can find particle methods like the ones below, like the ones that we are working with in the DEMpack. And that's what DEMpack is. It's a mixture between the interface based on GiD and a computing core based on Kratos. And on top of DEMpack is where SpreadDEM is designed. It uses everything behind, but also it adds new features. So it's partly based on DEMpack, Kratos and GiD, and fully developed inside CIMNE. After writing a paper in 2017 about modeling spreaders with particle methods, we presented the first prototype in Agritechnica, and after that we won a prize, a technical innovative prize in Zaragoza in the FIMA fair. We got our first client in 2018, and recently SpreadDEM appeared in the magazine World Fertilizer. Here we see a fast forward video of Merced using SpreadDEM, and we see a maximized window with a smaller window which controls everything. Here Merced is importing STL meshes containing disks, fixed parts, and we can see how all the data can be introduced by this central window. Everything that is introduced in the window is also reproduced as a graphical object, even rotation speeds, etc. Here we can see how Merced is introducing the granulometry of the fertilizer, the type of shape, etc. And here she's drawing an inlet with parameters, but as you can see, it is drawn immediately to see if what you are introducing as parameters is what you expect. Here you can also introduce the slope of the ground, wind speed, etc. All types of the parameters which can be needed at any time. Here we can choose the end time criterion. We can also choose the time step and the number of threads that the computer will be using. What we are seeing now are results. In the same window we can access the results which have been customized to fulfill the expectations of the industry. The spread pattern of fertilizer is plotted following the typical style of the industry. Here we see the coefficient of variation of the distribution of fertilizer, and you can also load very detailed results of the particles flying with the position of every particle, but you can also activate all types of results. You can stop the animation, play, draw the particle radius, increase artificially the size, etc. All the typical things that can be done in GiD usually, in GiD. Here we can see the velocity vectors, and of course you can scale them as needed. Using the contour field of GiD, You can also plot the maximum historical impact or the velocity at the moment of the impact of each particle, both in normal direction or tangential direction. You can even draw particle trajectories, as you can see here. You can pick any particle and the particle trajectory is drawn, which can be very useful for the designer. So why did we choose GiD, and how did GiD help us to develop SpreadDEM? Well, first of all, we can create new windows in the wizard style to control the underlying GiD. In particular, also, we use the importation of STL meshes. You can import it, you can visualize them, rotate them, etc. You can use the database of nodes and triangles, and you can export that to computational files. You can also draw symbols that give very useful visual feedback to the user, so they can know if the parameters they are putting have any sense or not. We also used layers handling, because you can change the color from SpreadDEM, you can change the transparency of layers, you can turn them on or off, and that's very useful. And also we changed the aspect of GiD. In particular, we removed the GiD header and we put our own. We removed the icons and we put our own. We removed information bars and we removed the menus because we didn't need them. We wanted to simplify as much as possible. And in the wizard window, we could embed results selector or the animation control, which was amazing. Well, that was all. I thought it was not too long for you guys. See you next time. This is the contact information down there. Bye.